used to be called a requirement, replace it with something else. And that's all about mitigating risk and maximizing return. So yeah, I agree with that characterization that all of this is about risk management.
I have a question. I agree that this point of view that that we need to change the way we think about quality and how we do things, and that we all have to be like craftsmen. But I want you to elaborate a little bit more how we get there. I like the example about the source, about the World War II, that they need a lot of source. And I have this feeling that we need a lot of source right now, and how we get all this source. It takes a really long time to be a craftsman. I don't know if you understand my question.
Okay, so how do we get a lot of source code? Like they got lots of swords in World War II. Actually, I don't have an answer for that. I think you just have to build it. Yeah.
So one of the problems in the world, I think, and there's huge numbers of problems, so this is maybe one of the minor ones, is that more and more stuff requires some sort of intelligence which is provided by software, and at an accelerating rate. So, 30 years ago, not that much stuff needed software to operate, but now you got to have software in washing machines and software in cars, and cars are computers on wheels, and everybody, the future of cars is that 90% of the innovation in car manufacturing is going to come from software. So the demand for software is astronomical, and it ain't going to get any less. It's just going to get higher. And the number of people capable of generating good software will not grow that fast. There's going to be a huge demand, and you can see it now, for people. And I don't believe that the number of people capable of developing great software is going to keep up with the demand for great software. Now, in history, whenever this has happened, some alternative mechanism for solving the problem has come on the scene. Most of the, for instance, in our country, most houses are built what's called stick-built houses with 2x4 lumber and sheathing. And the reason is because there wasn't enough logs and there wasn't enough stones. And there wasn't enough masonry or enough people. And those kinds of houses could be built much faster than any other kind of house, and they were the only way to solve the housing problem. If you go on and look at all kinds of other things, the reason why people were able to mass produce guns is because there was a war and there weren't enough craftsmen. So the solution to the problem, it becomes desperate, finds a way to come about. And so there will be a way to figure out how to create better and more software that will not be as dependent upon people. I'm not sure what the way is going to be, however. But I am pretty sure, if I look at the trends in history, that looking out not 10 years from now, but 15, 30 years from now, the kinds of software that we generate will be done much more compactly and effectively than they are now. I think it's going to come from designs for new parts. It's being done in medical device industry to generate some of the software. It's being done in very specific, narrow domains. And in those domains, they're getting better and better capability in that small section to automatically generate code. However, across the board, the concept of automated generated code, we've been around a few cycles of that. It was called case tools. It was called fourth generation languages. And the problem is, from a generic point of view, when you try to generically generate code, all you do is raise the level of complexity. I mean, the code is always going to go to the level of complexity that people can tolerate. And almost every general purpose automated code generator that I've run into doesn't have testable mechanisms attached to it. So very rapidly you get an untestable mess. If a code generator doesn't have a testing mechanism embedded in it, it won't succeed, because you're still going to get complex stuff, no matter how hard you try not to, and you still have to test it, and you still have to maintain it. So I don't have the answer to your first question, but as far as as far as code generators, I don't believe they're the answer.
You want to become a better, more effective professional so that you can deliver results faster. And if you think about it, there's only one way to go faster, and that's to go slower. What do you do with the extra time when you go slower? You think, you reflect, you improve your skills. You take time to get better so you can go faster. That's what lean implementations do. You slow down so you can go faster. You make sure that every time you detect a defect, you fix it immediately. You don't keep on running to get more code built. You stop and make the code you build perfect as you go along. Slow down to go faster. Learn. Learning is what makes the difference. Continuous, organization-wide, not just personally. You share what you learned with everybody else in your organization. You share what you learn with other people in your community. In future years, I expect to see many of you up here giving presentations, sharing your experiences, sharing your growth, sharing your triumphs. That's what is the core of a real Agile community, is that you learn, you share. That's how you get better.
Okay, one last thing, I'll be quick. These guys helped me realize my answer. Ruby. Learn Ruby. No. It's part of the answer. Maybe the solution is to reduce the amount of code we need, and Ruby will let you do that. With Ruby, you can write the same functionality in maybe 1/10 of the code that it would take in Java or C++. And it, no, it's not. But it's a gateway to a whole new land of programming languages. So check it out.
Okay, now, as the chief prognosticator, I got to add to that as well. Right now, the answer is Ruby. In another year, the answer will be something else. You guys got to keep looking to the future and remember what the real problem is and try to find the next solution. So the more people who are looking for the solution, the more people who are doing the research, whether it's through open source or anything else, the faster we're going to get there. And there's no reason why it can't come from South America rather than North America or anywhere else in the world.
Okay, so I wanted to know what will be your favorite practice, right? I mean, mine will be retrospectives, for example. So I want to know for each one of you what will be your favorite practice.
My favorite practice is a long tradition in software development. It's lunch. One of the advantages of using these approaches like Agile and Lean is you have more time for lunch. You're not chasing bugs all the time.
I can't possibly top that. That was completely brilliant, Dave. But I guess if I'm going to give a serious answer, not that that wasn't, it was a beautiful answer. For me, if you don't reflect on what you do, you never get better. So whatever you call that meeting that you have regularly, if you call it, a daily reflection or a weekly retrospective, it doesn't really matter. But if you're not stopping and looking at what you're doing and identifying the problems, you're never going to improve. So I guess it would have to be that.
So being the counter voice here, I don't actually like retrospectives. Yeah, right. Okay, so I come from an era of what is called classic process improvement processes. Good, solid, plan, do, check, act. Use the scientific method to solve problems, one problem at a time. Put aside time every week, a couple hours, and have the team use classic process improvement processes. And sometimes retrospectives get close, but generally speaking, they're a little bit weak in their mechanisms, and we already have in our toolkit some really effective process improvement and continuous improvement mechanisms, and I think we should look beyond retrospectives. And certainly, we've got to figure out how to constantly improve, but there's some really good tools that are okay, 15 years old, so you might not have heard of them. But if you take a look at, for example, the Team Handbook by Peter Schultes, you'll have a guidebook for the best of the classic process improvement processes, using data and gathering information and creating hypotheses, finding out what the real problem is, running experiments, looking at the results of those experiments. When they're successful, adopting the new procedure. And classic process improvement processes are something that I think maybe go beyond retrospectives to something that's really important.
Rather than practice, I'd say value, and I think it is trust. Now, if you wish to be trusted, you must be trustworthy. Are all of you trustworthy? Does any of your code ever cause problems in operations? Are you doing something to make sure it doesn't? Are you learning from things that go wrong when your code goes into the wild and starts interacting with the rest of the ecosystem? Are you making sure that you have tested your code in a way that it will never fail in an ungraceful way in operations? So becoming trustworthy, making sure that people are eager to deploy your code because it never causes them any problems. That's my favorite. That requires very deep levels of craftsmanship. Very, very deep. It requires learning from everything that goes wrong. Root cause analysis of everything that has kept people up at night, that has caused them to make mistakes.
Refactoring, that's my favorite. You know, when I'm refactoring code, I feel like a sculptor just chipping away pieces of rock, revealing the beauty in the software. And after, deleting code is the best feeling. When you can get rid of unneeded code and it still works. So there you go.
Well, I'm a coach, and I hardly ever get to practice the practices. But what I find, along the lines of what Tom is saying, what I find is the most satisfactory to me is that you guys have a favorite practice. That there's something that you guys like to do that you feel comfortable with and that you think helps. So as long as somebody has something, then that's what I like the best. So if I had to pick one, if there was a practice called transparency, that's the one I would want. But there isn't one, so.
Why isn't it?
Well, because I didn't write the set.
Well, just expand the set.
Well, I did on some of my slides.
Oh, good.
Okay, thank you. The question is for academic environment. Have you ever used Agile methodologies to execute research projects, not just to develop software to satisfy someone's needs, but to validate a hypothesis?
Who's the question? Micah.
I don't know, someone.
Let me just throw a real quick one out there. Have you guys ever heard of the Segway? You know what it is? That dweeby little scooter thing?
La patineta. La patineta metálica que uno va con un pie avanzando rápido.
No. La del motor.
Yeah, again, that thing.
El motor con dos ruedas.
Más o menos, es la idea. Come on.
There was no way that anybody would know that that thing ever would work. We used a Scrum methodology to produce it.
not sure I quite understand your question, which is, have we ever used the scientific method to develop code? Is that what you're saying?
To research. To a
Oh, in research?
project.
Well, I would like to introduce you to Dr. Tobias Poppendieck, who has a PhD in physics. He doesn't usually use the title because it doesn't seem to, add much. But anyway, he most certainly used the scientific method in research in, what was it, solid state physics? Yep. And got a PhD doing it. So, in fact, anybody who has a PhD has used this as the standard part of their research. This is the way research is done for any kind of a PhD degree. Hmm?
A PhD in poetry.
No, his is physics. Okay, any kind of a science PhD. Let's.
Bueno, estamos con el tiempo justo, se terminó entonces el panel, así que les agradecemos a todos los speakers. Stay there or just...
I think we should give the organizers of this conference a great big hand.
Bueno, ahora Martín va a hacer como un cierre general, un resumen, 5 minutitos como para contarnos también un poco cómo vamos a seguir para adelante y cómo pueden pasar a formar parte de esto, desde este lado un poquito.
Bueno, muchas gracias a todos por venir. Thank you very much to our guest speakers. I'll do that in Spanish to go faster. So, I'm sorry. You'll get most of that. Bueno, empezamos este evento hace bastante poco, en diciembre del año pasado, y surgió ágilmente. Es increíble verlo ahora, y ya me estoy trabando. Y bueno, intentamos, el objetivo principal era compartir nuestras experiencias alrededor de la metodología y demás, y aparte juntar a toda la comunidad, empezar a formar comunidad. Sabíamos que todos ustedes estaban ahí, algunos nos conocíamos, muchos nos conocemos, no todos. Estamos tratando de estar en contacto entre todos nosotros y seguir adelante con esto, con un espectro más grande de gente participando. Algunas de las cosas que queríamos mencionar era, tuvimos más de 400 asistentes, impresionante la cantidad de gente y sobre todo la permanencia de todos ustedes acá. Tuvimos las salas llenas prácticamente todo el tiempo y muy poca gente se fue. Obviamente algunos tenían cosas que hacer, pero en general todos estuvieron mucho tiempo y están todavía acá muchos. Tenemos que agradecerle obviamente a todos los sponsors, que ustedes ya los vieron por todos lados, no los quiero mencionar uno por uno, a muchos de los colaboradores que se sumaron, algunos de los voluntarios que vinieron a ayudarnos, a Carlos